without polymer, the life is not colorful life. Uh, Everywhere is polymer in our class also, in our home also. The bottle we use, the bag we use, is all are made up of polymers. So I will explain about the classification of polymer on the basis of source, on the molecular force, and types of polymers. So let's start. What is polymer? Polymer is a word derived from two Greek words. Poly means many and mer means unit. Polymer is formed by the monomer. When so many monomers, n numbers of monomers combine together, it forms polymer. And the process involved is called polymerization. If two polymer involved is called dimer. If three monomer is involved is called trimer. If the term polymer is defined as very large molecules having a high molecular mass, I want to tell you all that all polymers are micromolecules, but not all micromolecules are polymer. Let's understand
macro.
Micromolecules.
Macromolecules.
Sorry, I have a little bit confusion.
Yes. Macro.
Yes. So macromolecules. I will explain with the help of example. Chlorophyll is not a monomer, and polymer is formed by the monomer. If so many monomer combine, it form a polymer. So if there is no monomer, there will be no formation of polymer, but there will be a formation of macromolecules. Like example, chlorophyll. Next. And I told you this the process which involve monomer get combined. This process called the polymerization. This is a monomer which combine together and form a linear chain like structure is called polymer. The process involved is called polymerization. I have taken some example also here. The monomer like propane. When so many propanes combine together, they form a polypropanes. We know toys and pipes are the examples of these polypropanes. And vinyl chloride is also an example of polymer. When so many vinyl chloride combine together, they form a poly PVC or polyvinyl chloride. So next. Now discuss about the classification of polymer. There are the four classification based on it. First is source, second is polymerization, third is molecular force, and fourth is structure. So next. Now this structure is also classified in three ways, and polymerization is also classified in two ways, and molecular force are four types and source are three types. Let's discuss this briefly. If we will go through the source, the first is natural polymer. The word itself is saying the definition of natural polymer, which occurs in nature's natural way. Like plant and animals these polymer are found in the plants and animals. Like example, protein and cellulose are the example of natural polymer. If we will go further, semi-synthetic polymers are the natural. When we take a natural polymer and add some chemicals and all, they form a semi-synthetic polymer. With example, I will explain it. Let's take an example of cellulose nitrate. Cellulose is a natural polymer. When we add a nitric acid on it, it forms a cellulose nitrate. Now we will go through the synthetic polymer. The example itself is saying the definition of synthetic polymer, polythene, in which it is a fully chemical process. By crude oil, it is formed. So some examples are plastic, nylon fiber are example of it, and man-made chemical process is involved here in the laboratories. Now we will see classification based on the structure. It has been described in the three ways: linear, cross-chain, and branch-chain polymer. Linear polymer. Linear means a linear shape like structure is long straight line, and it have a high melting and high density because the molecules arranged are in a very tight packed manner. That's why its melting point is so high. An example of high density polyethylene and PVC are the example of linear polymer. Let's move and a branch chain polymer. It's a diagram, and it is clear that the linear polymer have some branch structure on it. So its example are low density polyethylene have a low density and low melting point because of the branch. The molecules are not closely packed, so its melting point is low. Cross-link polymer or network polymer. They have a bifunction or trifunction monomer. Like bifunction, trifunction, like a functional group is attached on it. Some example are bakelite and melamine, and they are having a strong covalent bond in it. So that's why they have a high melting point and boiling point, and they are hard and brittle. Now let's move forward and see. This is the polymerization classification based on the polymerization. Two types of polymerization are involved: addition and condensation. Addition, in which the repetition addition of monomer is took place, and in which double and triple bond are formed. We can see ethane which have a double bond in, and when n numbers of ethane is used for monomer, and by polarization the polythene is involved. So this is the addition, and we can see there is no elimination of small molecules involved like water, alcohol. In condensation the elimination will be there, molecules like water and alcohol. And homopolymer, in which a single monomer is used. See, this is single monomer is used. See, and in copolymer the two different monomer will be used. I have shown by this different colors. That is called copolymer. This is my first presentation in English. That's why I'm trying my best to explain English.
Good.
So condensation polymer. These polymers are formed by the elimination of small molecules. But in addition polymer, there is no elimination of small molecules like water and alcohol. In which we can see nylon 6,6 is formed by adipic acid and dihexamethylene diamine. Nylon 6,6 is formed, but H2O is eliminated here. In condensation, the first definition itself is saying the elimination of small molecules will be formed. In second, there will be the monomer. This type of use are bifunction and trifunction is nature. They will have a functional group, two functional group, or three functional groups. This is condensation polymer. Now elastomers. We are all familiar. This is the classification based on the molecular force. First, elastomer. We are familiar with the rubber bands. They have elastic in nature. When we stretch it, then it come into original shape because it has some cross link. They are weak intermolecular force of attraction in between them. That's why we can stat it. And the examples are rubber band and gunas are the example of it. Thermoplastic. When we heat the thermoplastic, it gets melts and we can reuse it. So it have a reversible process. But in thermo setting, we cannot recycle process is not involved, and they do not contain any cross bond. So it's having a weak intermolecular force of attraction between them, and they are soft when they are heated. An example are polythene. Thermosetting. We can see they have a cross-link bond. That's why they have a strong intermolecular force of attraction. When we melt it, we cannot reuse it. So it's an irreversible process. And some example irreversible in nature. And the examples are bakelite.
Where is bakelite used? Where do you use bakelite? Say any examples of bakelite?
Not getting.
The handles of pressure cooker and other non-stick cookwares are made up of bakelites. है ना? You see when they get melted, है ना? We cannot reuse it. We can remold it. But in thermoplastic, you said earlier, like in this, है ना? You said it is polythene. Polythene can be remolded again.
Yes, sir.
है ना? Polystyrene can be remolded again. So there are several plastic chairs in the home and all the other institutes. They come under the thermoplastic category, है ना? But the bakelite, like the handles of cookwares and all, है ना, they comes under the thermosetting plastics, है ना, which cannot be remolded again, and it is useless afterwards.
Fibers. They have a high tensile strength. They have a high intermolecular force of attraction is very strong in between them, and they have a high melting point because they have strong intermolecular force of attraction between them. They have a high tensile strength, and they are long, thin, and thread-like structure. In itself, we are known this fiber. We are all familiar with it. We use in our daily lives. Example are nylon 6,6 and polystyrene. Liquid crystal polymer. This topic is very interesting. Liquid crystals means the things which show both the characters, liquid and crystal. Crystal, which is we know that it is in a solid form. So the process, let's take an example. When we have a solid, we start heating it. So it will convert into a liquid, but there will be a in state in between them, the have I'm not getting the word, hazard state or
Which?
so the state where the solid and liquid, the both the character will show. Like sodium chloride have an 80 degrees Celsius melting point, but in 700 degrees Celsius it will be like a solid, but it can be flow. That's that state is.
Even I'm not also getting it. It's in the mouth, tip of the my mouth, but not getting it.
Hazard.
कुछ और होता है. Let it be.
Yes, sir.
We'll see
The
it.
state, that is state where the crystals or the solid, which the example is both the characteristic we showed, solid and liquid. The property where between the solid and the liquid occur this with a definite temperature range. They the polymers which have the property like liquid crystals means it will behave like a liquid as well as a solid, and have aromatic mesogens. Mesogens are the liquid crystal property, the compound which have a liquid crystal properties, and they have a rigid rod like and a plate like structure, and they have a disorder solid and the order liquids. Disorder solid means they are not in an order way, and the order means they will be in a order form, in a pattern form, in a liquid form. Yes, sir. Next. These are the classification of liquid crystals, and this is also the example of liquid crystals. So first the thermotropic means it will be on the temperature. It will be based on the temperature. Next. See, thermotropic liquid crystals which are based on the temperature range is called the thermotropic liquid. Nematic liquid crystals which have a thread-like, nema itself the Greek word which means a thread-like structure. So those liquid crystals which have a thread-like structure is called a nematic liquid crystal. They do not have a pattern order. See, they do not have a pattern order. When particles align towards or axis the rotation, they will have some axis on around the it will be on x-axis or y-axis, and they do not have the pattern order. And these thermotropic liquid crystals are three types. This is the first type, nematic liquid crystal. Second, this is the second, nematic liquid crystal.
Smectic.
Sematic.
Smectic.
Sematic.
Smectic.
Smectic liquid crystals. They are in a order pattern. Order pattern mein, and they are in a same direction. It cannot be only in x-axis, it can be in a y-axis, but they all will be in a same order. And this smectis means a soap-like or slippery. So these crystals that have a soap-like structure and slippery in nature is called a sematic liquid crystal. This is second one, and the third one. This is a calostrolic liquid crystal. Liquid crystal that have a cholesterol-like structure, and they will have a layer like a structure. This layer is different. This all layer will be in a different form, and they are arranged in a layer form. They have a different orientation in each layer. We can see these have a different orientation. This layer have a different orientation. All the layers these have a different orientation. Next slide. Now, lyotropic liquid crystals, those liquid based on the concentration. Example, we say this: when we add a surfactant, when we increase the concentration of it reaches into the CMC, critical micelle concentration. So the micelle formation is done. So example is micelle because they are based on the concentration. Surfactant concentration increase, it reaches to a CMC level. Now despotic, which have a disc-like structure, and salamatic, which have a rod-like structure. And metallotropic liquid crystals, the metal salt which behave both the character like solid and liquid. Liquid and solid, the metal salt will behave both. The zinc chloride is an example of it. It behaves both as a solid and a liquid. Next is fire resistant polymer. The polymer which are used for resist यानी होता है प्रतिरोध रोकना. तो which is used in a polymer जहाँ पे चीजों को आग से बचाने के लिए यूज किया जाता है. To minimize the fire hazard, fire retardant chemical added to a polymer, additive chemicals are added to a polymer during the polymerization. The the process we do for making a polymer. The additive which are used for putting in the process of polymerization, which retain the fire, is borax, metal hydroxide, and halogen. These are the examples. They are strong, tough, and durable. See, if the fire resistance, the man here standing, he will not get a heat up to 45 minutes. But if is in normal protective layer, the heat will be involved. It will be gone there. So it is the most important polymer because it heat resistant. They have low flame spread here and a minimum heat, smoke, and toxic gas. Metal hydroxide they use hydrogen borax and borax is used as a fire resistant in a textile industry. Textile industry means like buildings and all for resisting during the fire. It is used there. Next page. These are the application of fire resistant clothing and industry. We see the fire brigade when they are wearing this cloth because they have a sufficient for fighting from the fire. They have fire resistant involved in during the polymerization process. Borax and all examples of this fire related. Thank you so much. This was my first presentation in English, so I tried my best. I always try to speak in Hindi and I well do it. I do good in Hindi. But I try my best to speak in English and definitely I will improve it. I know I done many wrong things and my pronunciation is not good because I was not good in English in my school life also. I done all my graduations and all my school lives in English medium also. But our teachers were also speaking in Hindi, their lecture were going on Hindi, and we always we are speaking in Hindi also. Only we are writing an answer and questions in English, but we are speaking always in Hindi. But I am trying to improve it, and I will improve. Thank you so much. If you are having any doubt, you can ask me that. I will afterwards. I will once again. I will tell you this personally in Hindi.